Section 2.1, Introduction to Fractions and Mixed Numbers. Let's get started here. Okay, these objectives, we're going to understand the basic concepts of fractions, graph fractions on a number line, understand the basic concepts of mixed numbers, graph mixed numbers on a number line, change mixed numbers to improper fractions, and change improper fractions back to mixed numbers. Okay, let's jump right into this. And notice, okay, example 1. Understanding fractions. Okay, write a fraction indicating A, the shaded part of the rectangle, and the unshaded part of the rectangle. Okay, looking at the first part, what we're going to look at is how many rectangles are there. Okay, we've got one main rectangle here that is subdivided into 1, 2, and 3 places. Okay, so it's got 1, 2, 3, 4 subdivisions. Okay, notice the shaded part, okay, in the rectangle. 3 of the 4 equal parts are shaded, so thus we would write that as 3 out of 4 are shaded. Okay, well, what parts are not shaded? Well, the part that isn't shaded is right here, and it's only 1, so 1/4 is not shaded. Okay, and that in a nutshell is exactly how fractions work. We'll do some more examples. Okay, write a fraction indicating the remaining portion of the pizza and the missing portion of the pizza. Okay, the pizza was cut into 8 equal slices. Notice we can come over here and go 1, 2, 3, 4, 5, 6, 7, and 8. Okay, the 5 pieces remaining, which are these parts here, are 5/8 of the pizza. The missing portion of the pizza represents, well, how many pieces are gone? Notice we have 1, 2, 3 pieces that are gone, so that's going to be 3/8 of the pizza. Okay? So, a proper fraction is a fraction in which the numerator is less than the denominator. Proper fractions have a value less than 1. Okay? These are all examples right here of proper fractions. Notice the numerator. Okay, this part is the numerator. Okay, is larger than the denominator. We'll call this right here denominator. Okay, always. Okay, proper fractions always smaller on top than they are on the bottom. Continuing on. An improper fraction is a fraction in which the numerator is greater than or equal to the denominator. Okay, improper fractions have values greater than or equal to 1. This will become more apparent later on. We won't kind of hang out on this too much right now. Examples of improper fractions. Notice 15 is larger than 8. Okay, it also said that I could have this right here. I could have 14 over 14. That is just fine. Okay, so these are all examples of improper fractions. Okay, this is terminology that you're just going to learn about. We'll use the term improper a lot more than we use proper. Okay, draw a figure representing the fraction 5/6. Solution: 5/6 indicates 5 of 6 equal parts. Drawing a figure to represent this fraction, we divide a circle into 6 equal sections and shade 5 of them. Notice this is exactly what just happened. We drew a circle that has 1, 2, 3, 4, 5, 6, just like our pizza example. Okay, but notice here that it says just shade 5 of the places. Okay, which is why we just shaded these places right here. Okay, and that gives us the fraction right here of 5/6, and that right there would be a proper fraction. Okay. Here is understanding improper fractions. Write a fraction that indicates the shaded part of the figure. Okay, there are 2 squares, each separated into 3 equal parts. Here they are, 1, 2, 3, 1, 2, 3. This means that the denominator is 3, okay? The shading here indicates 5 of these equal parts, which means the numerator is 5. Thus, the shaded part of the fraction can be represented by the improper fraction. Notice, we've got 5 shaded areas, so it'd be 5 over what? Well, 5 over 3. Okay, that's how that will be represented. Okay, and you can change this back. We'll learn how this right here, the way this symbol looks right now, may look a little weird, but this is going to become more apparent as we kind of move forward in our definition today, especially when we get into something called mixed numbers. Okay, continuing on. A variable is a symbol, generally a letter of the alphabet, that is used to represent an unknown number. Okay, so instead of saying like 3, we might use the letter X. Okay, we're here, X is represented by 3. X is equal to 3. But we could also just have an unknown. We could just have a letter A in our example. We could have a letter Z. There are some numbers we tend to stay away from. We could even have Greek letters. We could have capital letters. Okay, you've seen that before whenever we have formulas sometimes. Okay, they'll have capital letters. Everything represents a certain number. Okay, let's continue on. The number 0 in fractions. For any non-zero value of b, 0 divided by a number is equal to 0. Okay? For any value of a divided by 0 is undefined. Okay, this right here is just going to be, remember this. Okay? Remember this, because if I ever say to you 5 divided by 0 is what, and you say 0, I'm going to say no, it's undefined, okay? But if I say 0 divided by 5, then you're allowed to give 0, because 0 is a number, okay? It is defined. Find the value of each expression. Well, just like I said, 0 divided by anything is always going to be 0. So notice here for A, we're good. Well, let's go to B. Once again, 0 divided by anything, always 0. Okay, but 17 divided by 0, can't have that. Okay, so I'm just going to put UDF for undefined. Okay, and the same thing here, undefined. But here's another little side note. 0 divided by 0, okay, that is still undefined. Okay, that is very important. Anything divided by 0 is undefined. Let's continue on. Okay, we're going to graph each proper fraction on a number line. For this first one here, what I'm going to do is going to start a number line here, and this is what it's going to look like. I'm going to have a number line here, and we'll have it go from 0 to 1. Well, notice here, my 5. That means this is divided into 5 equal parts. So I'm going to go 1, 2, 3, 4. Okay, so here would be 1/4. Here would be 2/4, 3/4, 4/4, okay, or 4/5. I've been putting fourths in here. I'm very sorry. Don't know why I've been thinking fourths all of a sudden. 5th, 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 and then this one right here would be 5/5, because 5 divided by 5 would equal 1. So this right here is exactly where 4/5 would be. Let's continue on. Same rule applies. Come in here, I've got a number line again, okay, except this time I'm going to start at 0, and I'll still go ahead and end at 1, but instead of having 5, notice I'm going to look to my denominator and know that I've got to split this up into 7 places. So I've got 1, 2, 3, 4, 5, 6, 7. So when I want to do the 2/7, I can come in here and go, well, this right here is 1/7, and this right here is going to be 2/7. And we could continue on, but we don't need to, because notice here is going to be my 2/7. Okay, and one last example here. We got 5/6, and by now we should see that we can start 0, and then we could have 1, and then we can come in here and go, okay, I've got to divide this into 6 equal places. So I've got 1, 2, 3, 4, 5. And then, of course, my 6 is going to be on this part here. Okay, because this, remember, this part here is 6/6. It's got to equal 1. Okay, so coming in here, now I can go here to the 5. 1, 2, 3, 4, 5. And right here is going to sit 5/6. Okay, now we're going to graph the following improper fraction on the number line. Okay, these can look a little bit different, but don't get too freaked out by them. Notice I'm still going to have a 5 here, okay? So let's kind of get through that. So I'm going to come in here, I'm going to draw a number line. I'm going to make it a little longer this time. I'm still going to start at 0, but right here I'm going to put a 1. And then right here I'm going to go ahead and put a 2. I'm still going to look at this denominator here. So I'm going to go ahead and divide everything out here into 5 equal places. So I've got 1, 2, 3, 4. Here's my 5. Then I've got 1, 2, 3, 4. Here's my 5. Well, same thing applies. Notice I'm going to go over 7 places. I'm going to come over here and go 1, 2, 3, 4, 5. Well, here's my 5, but then I go 6, 7. Okay, so right there would be 7/5. This should kind of let you know now, and hopefully kind of help you understand what this meant a little bit more. Okay, notice we have a whole section of 3's, but then we had to go over 2 more than what was actually there. That's the reason for improper fractions. Okay, and yet, like I said, you're going to see these a lot more later on. Okay, identify each number as an improper as a proper fraction, improper fraction, or mixed number. Okay, this first one is my denominator larger than my numerator. Well, yes, 8 is larger than 7, so this is going to be improper. Oops. Helps to spell it right. Okay, here, notice I have a fraction right here that looks like a proper fraction because my numerator is smaller than my denominator. But then right out here, I've just got this whole number sitting around. Well, anytime you have that, notice I've got a whole number and a fraction. Well, that's our definition of a mixed number. And then looking at our last one, notice it's going to be the proper fraction because here it is, it says down at the bottom. But notice the reasoning is my numerator is smaller, and so we have a proper fraction. Okay, to change a mixed number to an improper fraction, okay, we're going to multiply the whole number by the denominator of the proper fraction, add the numerator of this proper fraction to this product, and then write the sum over the denominator of the fraction. Okay, how does this work? Okay, multiply the whole number by the denominator. 8 times 10 equals 80. Add the numerator, plus 9 equals 89, and then write the sum over the denominator. What I like to do is I sometimes used to tell my students, this is the big C method. Take a line and draw it all the way around it. I've got 10 times 8 plus 9. So 10 times 8 is 80, plus 9 is 89. And then keep the 10. There you go. If you kind of remember that. Multiplication, addition, keep the denominator. Okay, that's how you go from mixed number to improper. We're going to do that a lot. Okay, as you get further up in math, these numbers become a lot more important. We like them a lot better. Believe it or not, you're going to like fractions a lot more as we kind of go through this. Okay, to change an improper fraction to a mixed number, divide the numerator by the denominator. Okay, the quotient is the whole number part of the mixed number. Write the remainder over the denominator as the fraction part of the mixed number. Okay, kind of kept this one as an example here. Change 67/5 to a mixed number. Well, here's what they did. Notice I'm just dividing 5 into 67. 5 will go into 6 one time, multiply the 5, subtract it off, get a 1, bring down the 7. Okay, I've got 5 will go into 17 3 times. 3 times 5 is 15. Subtract, I got 2. Okay, notice this is now, you can see everything here. You've got the remainder, you've got your original denominator right there. Just put that there, and then right here is going to be the top. So that's going to be your new, basically your numerator. Okay, the whole number part. Okay, not the numerator. I'm sorry. You got 13. Here's your numerator. The 2 is your numerator, and then you've got the 5. So remember, the remainder here, okay, is your numerator. Okay.